Okay. If f of x equals x squared, now follow this carefully if you don't understand it. X has been replaced here by x minus 10. Do we see that? We have f of x minus 10 where we have f of x before. So this x has been replaced by x minus 10. That means that we got to replace this x by x minus 10. So f of x minus 10 is x minus 10 squared, because that's what we get if x in this expression is replaced by x minus 10. Okay? If you didn't understand that before, make sure it's starting to make some sense. And say, okay, now we have f of x minus 10. Well, do we have an expression for f of x? Yeah, f of x is x squared. So we can replace f of x by the expression x squared. We don't do anything to the x squared with that negative 10, because that negative 10 isn't part of what isn't part of the definition of f of x. Now we got to have the minus 10, but it's not part of our definition. So it's x squared minus 10. Okay. Now, f of 2x minus 10, x has been replaced by 2x minus 10. So replace both of these x's by 2x minus 10. We get f of 2x minus 10 equals 2x minus 10 quantity squared. Okay. Now, what about 2f of x minus 10? Well, the 2 has nothing to do with what's inside the function here. So we're going to do f of x minus 10, placing x by x minus 10, we get x minus 10 squared. And I didn't leave myself room for it. But then there's a 2 multiplied by that. Okay, so the 2 doesn't go in the parentheses. Everything that goes in the parentheses is what's inside here, because that's the only thing that's getting squared. Now we've got this one. I'm going to have to write down here. 4 f of x minus 10 plus 10 equals what? Well, we have f of x minus 10. Again, x has been replaced by x minus 10. So we replace this x by x minus 10. We get x minus 10 squared. So that replaces f of x minus 10. And then we got 4 in front of that. And then a plus 10 after that. Okay. That's the pattern. It's a simple pattern except practice. I don't know how Open Math explained it. I find that this is the simplest way. Substitution. This is substitution, okay? So make sure you got that straight. Now, if f of x equals 2 to the x, f of x minus 10, wherever you see an x, you got to put a 10, x minus 10. So for the x unit, okay? And then f of x minus 10. Well, f of x is just 2 to the x. So we have 2 to the x minus 10. And f of 2x minus 10, we replace x by 2x minus 10, because 2x minus 10 is right here for the x was. 2x minus 10. Okay. Skip the next one, I'll do 4 f of x minus 10 plus 10 equals f of x minus 10. Place x by x minus 10, we get 2 to the x minus 10. There's 4 in front of it. It's not there for multiplication. Plus 1. Oh. Okay. If it's a reciprocal function, I'm just going to write them down without a lot of explanation. Now, looking at this. Again, I'm a bit at a loss. I really kind of need an explanation here. I don't really need an explanation on the function notation. Although, if you missed it or know somebody that you thought might have missed it, you can maybe write me a little note saying, how did you get through the open math and then not know this? Okay. Again, could be, and I caution against, that you're just imitating examples without thinking about them. And you're always looking at an example when you do a problem. Problems don't have videos, don't have examples. You need not be looking at anything else. And you need to pull it out of your memory after having seen it, maybe by imitating the video or imitating the thing. Okay? If you're not doing that, you're not going to learn it nearly as well. You might not learn it at all. Okay? So you really need to be sure that you approach it that way. Not the way you learned in high school. Also, I realize everything I just wrote there. Little graphs, it's off the screen, so there it is on the screen. Okay. I didn't say anything about it. I just wrote them down, so there it is. Okay, so let's. I gotta say I don't understand what the problem is here. So I'm just going to say it. I recommend you go to the video and listen to what I say, parse my words until you understand it. Okay. I'm going to say it as clearly as I can. I'm going to do this, but I'm not going to do this. First of all, this point here has x coordinate 12. The x coordinate is the same everywhere on a vertical line. So that on this vertical line, x equals 12. Okay. On this horizontal line, you have a point with y coordinate -8, so we know that y equals -8 everywhere on this line. Similar to the fact that y is 12 everywhere on this line because this point has a y coordinate of 12. And x is 8 everywhere on this line because this point has x equals 8. Means if you got the x-axis down here someplace and this line continues on, it's going to hit the x-axis at 8. And so is every other point on this line. Okay? Gotta understand that. Keep thinking about it until you do. Okay, now another problem here is it's a 4x4 rectangle. I'm going to do a little bit with a 4x4 rectangle here. It's square, but it's also rectangle, so I call it. How far is it from here to here? Hold up fingers. How far from the center line to the right edge? 2 units. Okay. Now we do the standard construction where, well, this is halfway between the edge and the center. How far is it from the right edge to this vertical line? 1 unit. Okay. Now, how far is it from this line to this line? Well, it's half a unit. Everybody understands that. Okay. Because we just cut something that's 1 unit apart and we put something in the middle. So we're halfway. So we have a half. Okay. So now, if this line is x equals 14. What's this line? And let's not say 14, let's say this is x equals 7. We can hold up fingers. So this is x equals what? Okay. Well, if this is x equals 7 and it's 2 units from here to here, and x is increasing in this direction, as I hope everybody knows, yeah. Then you gotta have x equals 9, right? It's about 8 or 9. Because you told me this is 2 units. Implicitly, x increases in this direction. So x has to be 9. So, what about this line? No picture. I think we've got 8 fingers up. This is x equals 8. So, what's this line? Like this line would be 12. You do 12, 1, 2, right? What's this? Yeah, 13. Okay. Because it's 1 unit. See how easy this is? All you have to do is see it. Okay. Like that picture of an old woman, young woman. Once you see it, you see it. Has everybody seen that picture? What's happening out there? It's pretty standard anyhow, because I can't refer to that either. But that's okay. See, x equals 13. Once you see it, you have it. Okay. Now, if this line is y equals 9, then what's this line? I'm seeing a lot of answers that are sort of reasonable, not quite right. Yeah. Does y get bigger in this direction or this direction? Y gets bigger in this direction. So instead of 11, not oriented. Okay. start get oriented. Y gets bigger this way, right? So now what's this? It's going to be 7. Okay. Now I would think everybody in the universe who graduates from high school would understand that about numbers on a graph instead of coordinate axes, but it's not so because y'all are smart people, okay? And you don't have it. I don't know what else you're missing. So we got to kind of, there are always surprises, okay? So I'm a little surprised by this, but do you see how simple it is? Very, very simple once you see it. Until you see it, just jump, okay? So this is y equals 7. Why is it y equals 7? Because it's 2 units from here to here. And everybody implicitly saw that. He just said it left, and he saw it was 2 units. Okay? Well then, this ought to be easy, right? Okay. Okay. And it's y, because y is the same everywhere in this line. If you got a y-axis over here, then this line's going to hit it at 8 because y is always 8 on this line. Because 8 on the axis is horizontally over from every point on this line, right? That's what it is. And okay. Now, which function would contain these 3 construction lines? And we can say 1, 2, or 3. Squaring, sorry, exponential is the first one we saw. Squaring, reciprocal. Okay, so which function would have those lines on it? It might be more than one. So if you think it's the exponential of the squaring function, you can do this, right? It's not all 3 of them. Might be 1, might be 2. So couldn't see your whole hand. It looks like you might have this actually. No. Okay. Okay. It's the reciprocal. Okay. Now, what line don't we get for the others? 1, 2, or 3? Which line's not going to be there? Okay. This line's not going to be there for the squaring or exponential because of the rule. Now, everybody did a good job of drawing these things in the first day. Okay. But occasionally I see a graph that has a line in a very strange place. Okay. Doesn't correspond to the construction line. I've seen it that often, but if you're putting lines in the wrong place, make sure you understand the rules for construction. Halfway from the top edge to the bottom, halfway from there to the bottom, halfway from there to the bottom, and halfway. Another thing that I see on some graphs is this. What's wrong with this? Now, these lines are maybe more or less equally spaced, and they'll never be. Except for the exponential function where you have equally spaced lines because you go halfway from the edge to the center and halfway from the edge to the center, which means the center line and the 2 new lines, they're all equally spaced at the edge, right? Okay, so I see something like this, I know that you need to review how to do these instructions. Once you know how to do them, you know where they are, and you can tell what's happening between what you get to later. Okay. make sure you can label these things. It's really going to know. Can't make estimates. If you can't label them, then we're going to make estimates. Okay. Well, okay, there's a picture of our standard exponential, right? Let's assume that the vertex is at 0, 0. It's the basic toolkit function. Vertex is at 0, 0, and its square is 4 by 4. Okay. X equals what here? Well, it's a little closer to the right edge than it is to the center. And the right edge is at X equals 2. 0, 0 here. Seems 4 units larger. This is 2 units, and this is 2. And you just need to know that. It's a little closer to this edge than this. So let's just say that X equals 1.2. Then you would estimate y is what here? Well, if you have your construction lines, your first construction line will be there, okay? And your next will be halfway to the origin. So 2 is going to be here and 1's going to be here. Now you can do this with construction lines. I'm just trying to get it kind of quickly. You see that this is somewhere between 1 and 2. And maybe you think this is about 1.5. So in function notation, as you know, you did the Simon functions, they told you how to calculate the values of these functions, okay? Which is using a graph, we're estimating it's 1.5, right? We could calculate it, we could put 1.2 in here. Hopefully you could do that without a calculator. That comes up pretty close to 1.5, but not exact. So I'm going to say f of 1.5, sorry, f of 1.2 is approximately 1.5 by the graph, okay? Of course, f of 1.2 equals 1.2 squared, which is 1.44. Say this is exact. It's pretty close to the estimate 1.5. Okay? Everybody understand that? Now, okay, what do you think y is here? Everybody make an estimate. Like if you think it's 2.7, do a 2.7. Okay. 2.7. I think it's probably not exactly 2.7. But what do you think Y is? You can give me a whole number if you don't want to do a decimal. I think it's probably not quite a whole number. What whole number do you think it's closest to? Okay, some people are saying 2, some people are saying 3. Okay, well, kind of reasonable. Let's say 2 would be right here. So 3 would be halfway between here and here. And maybe a little bit off of that. So maybe Y equals 2.5 on this line. You might think it's 2.7. I think it's 2.3. So on this line, we estimate that Y equals 2.5. Okay, so this line where it intersects the graph corresponds to f of x equals 2.5. Now, everywhere on the line, that's true. But at this point, f of x is 2.5 because f of x is the value of y, right? We say y equals f of x equals 2.5, or we just say f of x equals 2.5. Okay, well, what is x at each of these points? Okay, so write down 2 numbers on your paper, write them big and circle them so I can see them. Let's see what you think. Okay, if you didn't get something reasonable, I'll make sure you understand what I'm doing here. We want to find the x at this point. We want to find the x coordinate of this point. That's the x that makes y equal to 2.5. YRS. So x equals what on this line? And x equals what on this line? You understand why I do this? Because now if x is whatever this is, then the vertical line intersects the graph at the point that tells us what y is. Now, I told you what y has to be. You're trying to find x. Okay, so you think, if I do all my construction lines, for example, x equals 0 is here. It's written small, but there's a line for x equals -1. I can label it here. And what's x here? If you've got your construction lines labeled, you can make an estimate. Here, construction line here would be actually your edge line, x equals -2. So between -1 and -2, closer to -2, maybe it's -1.7. Now, if you think it's 1.5, a lot of people didn't put negatives in these. Okay. So you got to get a little bit oriented as to the left of x equals 0, you got negative values of x. So here x is negative 1.7 question mark. It's just an estimate. And this one, if we're honest, looks a little bit closer to the right edge than this one is to the left edge. So let's say that this may be x equals 1.8. Okay. Now some people have numbers a little over 2. Again, if you got your construction lines labeled, you won't make that sort of error. It wasn't a totally unreasonable number. It wasn't that far over 2, but I saw that a couple of times. So you understand why I want you to be able to label the construction lines so you can make estimates. Sometimes that's all you got. Sometimes that's all you got from a graph. Sometimes you're dealing with data and there's not a good formula for the function. Then you've got to look at the graph and understand what you're seeing. Now, usually the graph will be labeled for you for the purposes of this course. There are deeper things we're trying to understand by labeling this graph. Okay, you'll see them as we go on. So what is x at each point? Okay, well, now we can check that. What's f of negative 1.7 equal? Well, you see f of negative 1.7, and you know that f of x is x squared. So f of negative 1.7 is negative 1.7 squared. And f of 1.8 is 1.8 squared. This is 2.89. This is 3.24. Not all that close to 2.5. And that's mostly because my graph wasn't all that precise because I didn't make the construction lines and draw it carefully. You don't have to take hours to do it. You can draw a pretty careful graph in a minute or two. And you can make estimates and you can check your estimates against solutions to equations. Because now we're going to solve this equation, f of x equals 2.5. Okay, understand what we've done here? How to do this? You might need to go back over this. You might need to go back over. You'll read my words if the transcript's already good. My diction's fairly good, so there's no reason the transcript shouldn't be. I think I commented in the last class, the transcripts got really bad for a while of YouTube. A couple of years, it's just garbage. And before that, they were pretty good. Now I think they've gotten better than they ever were. I think. They started using AI before AI was ready to do it right. I think is what happened. I'm not sure. Got a former student who's a PhD mathematician, works as a trainer for Google. Comes by every once in a while. Tries to confuse me, and he's usually successful. He didn't really try because he didn't have to try. Good guy, good guy. So next time I see him, I might ask him about that. I never thought to ask him. Will was a part of Google. He might be sworn to secrecy. He might not want to admit it, so I'll give him an hour. Okay, well, basically, if you look at the transcript in Google, you kind of spot keywords, see what I'm talking about, what it is you don't necessarily understand, or you just kind of click through and find it. Okay, of course, yeah. This whole thing with the construction lines and everything, you're not going to find it anywhere else. Nobody else has a sense to do this. Okay. Again, the reason I did the construction lines was I thought it was easier for you to draw pictures than it is to do the algebra. I still think it's likely true for most of them. Okay. Pictures are manageable. You understand what I talked about today? And I think everybody hopefully is in shape to do that. Then you've got pictures, and we can use the pictures to understand some stuff. People usually don't understand, even at the end of the course. Okay, so let's see, we have estimated the solution of f of x equals 2.5. Okay. So this is the equation, x squared equals 2.5. Okay, there's an equation. Write it down. Don't write down the rest of my words. I'll take the time to write down that equation and write down the steps you would take to solve it. Okay, I'm repeating what I just said, but some people have one solution. Okay, but nobody has two solutions. And if you look at the graph, the x squared function has a graph that looks like that, and the line y equals 2.5 cuts it in 2 points. What are you going to do about the other solution? Well, you can say that x is plus or minus the square root of 2.5. And then you can punch that into your calculator. I think it's probably pretty close to hundreds to 1.57. There's the solution set. We list both solutions inside a set of set braces. Negative square root of 2.5, square root of 2.5. That's approximately equal. I use wave the equal signs for approximately 2. And I take your calculator and square 1.57. I think it's going to come up pretty close to 2.5. I think maybe just a little less than 2.5. Square 1.58, I think maybe a little more than 2.5. They'll be in that range somewhere. Okay. So we got a rule here. Okay, let's solve other. Now, the graph has not necessarily help with this equation until we learn about transformations, which is what we're building up to with these squares. You solve x minus 6 quantity squared equals 5. Okay. If x minus 6 squared is 5, then x minus 6 is plus or minus the square root of 5. If something squared is 5, the only thing you can square to get 5 is the square root of 5 or the negative square root of 5. Okay? And then you can add 6 to both sides, and we get x equals 6 plus or minus square root of 5. That's how you solve that equation. Now, a couple of things that people did that you want to be careful of. First of all, x minus 6 squared is not x minus 6 times 2. Now, x minus 6 times 2 does equal x minus 12. But this isn't x minus 6 squared. What is x minus 6 squared? Well, I'll show you up here. X minus 6 squared equals x minus 6 multiplied by x minus 6, which equals x multiplied by x minus 6 minus 6 multiplied by x minus 6, which equals x squared minus 6x minus 6x plus 36, which is x squared minus 6x plus 36. That's what it equals. Now, I'm not going to go through the details of that, but that's how you do it. We'll go over that. Okay. You need to understand the distributive law. Again, this is algebra 1. Okay. It's not x squared minus 6 squared. First place, you don't get a minus 6 squared. You get a plus 6 squared, which is plus 36. Second place, you got something in between there, which is minus 6x. Okay. You know it's not x squared minus 36 because x minus 6 squared can't be negative. There's no number you can square and get a negative. And x squared minus 36 can certainly be negative. So that's called a kind of reduction to absurdity. In other words, you take what you think and you see that x is the right number, you get something you can't get. Okay? Contradicting your assumption. And that's a formal reduction to absurdity. It's obviously not true. If you think about it, right? Okay, well, you don't have to know that, but you do have to understand that that's how you solve an equation of this nature. If something squared equals a number, then that something has to equal plus or minus the square root of the number. So that's something you want to store away because we use that a lot in this course. Okay. You have the assignment on domain and range. Open math is, we could talk about it a little bit with graphs. You're going to have to try to get it out of the open math. Try to get it as best you can. I will say that domain and range can be subtle and tricky. Okay, there are aspects of it that are pretty hard. The easy parts are easy. Comes down to you can't divide by zeros and you can't take the square root of a negative. Just apply those two ideas, everything comes out. I wish we had more time to go over that before we do the assignment. We have to get to these assignments. And spending a lot of time on some really basic stuff that's just kind of missing. So let's see how you do with that assignment. Let's see what you get out of it. And next, okay? Open Math does a nice job of telling you. But again, there are some things about it that are pretty tricky. Okay. Good luck on that, and we'll see what we have next time.